On February 1, 2025, the Astronomy Picture of the Day APOD showcased a breathtaking image of nacreous clouds over Sweden captured by photographer Vojan Höfer. These rare atmospheric phenomena, also known as mother-of-pearl clouds, are characterized by their vivid iridescence and occur at high altitudes in the polar stratosphere. The phenomenal display seen in this snapshot was taken on January 12 with the Sun positioned just below the horizon. The unique conditions leading to the formation of these clouds involve unusually cold temperatures that enable ice crystals to form, allowing sunlight to diffract and create stunning visual effects even when the Sun itself is not directly visible. As the cosmos continues to inspire awe, other significant developments are unfolding on Earth, particularly at NASA's Space Center. Recent visits by officials highlight the ongoing collaboration between NASA and various sectors, including agriculture, as the agency seeks to leverage its satellite technology for practical applications. Bradley Dorn, program manager for NASA's Agriculture Earth Action Program, emphasized the importance of satellite data in precision agriculture, stating NASA satellites are the world's premier satellites. These satellite programs are funded by tax dollars, so they should be put to work to really benefit the taxpayers. The integration of satellite data into agricultural practices marks a significant evolution in farming methodologies. Farmers now have access to real-time information that enhances their decision-making processes, moving away from traditional reliance on historical data and anecdotal evidence. This shift allows for more precise calibration of equipment, improved irrigation management, and better pest and disease control strategies, ultimately resulting in higher crop yields and lower resource consumption. But collaboration between NASA and agricultural researchers is also fostering innovation through initiatives like the NASA Acres program. The University of Illinois and several other institutions are working to harness satellite data for agricultural research. This partnership is focused on addressing critical challenges in farming, such as optimizing nitrogen levels and enhancing crop resilience. By tapping scientific advances developed by NASA for space programs, Dorn explained, manufacturers can provide products and services at lower costs to consumers. Looking ahead, the space sector is poised for an exciting year with a busy launch schedule from Florida's Space Coast. Following a record-breaking 93 orbital launches in 2024, space agencies and private companies are gearing up for new missions, including SpaceX's Starlink satellite deployments and Blue Origin's inaugural launch of the New Glenn rocket. The upcoming missions not only represent technological advancements but also underscore the importance of collaboration in achieving ambitious goals in space exploration. As NASA continues to bridge the gap between space science and agricultural innovation, the implications for both fields are profound. The ongoing dialogue between scientists and farmers ensures that technological advancements are tailored to meet the specific needs of those on the ground. These collaborative efforts promise to enhance agricultural productivity and sustainability while simultaneously pushing the boundaries of space exploration. In essence, the synergy between astronomy and agriculture exemplifies how advancements in technology can have far-reaching impacts across diverse fields. As we stand on the brink of new discoveries and innovations, the future holds the potential for even greater achievements in both the cosmos and on Earth. In a significant leap for private space exploration, Axiom Space's fourth private astronaut mission to the International Space Station (ISS) is set to launch with a diverse crew that exemplifies international collaboration in space. Scheduled to lift off from NASA's Kennedy Space Center in Florida no earlier than spring 2025. The Axiom Mission 4X4 promises to continue the trend of expanding access to low Earth orbit for private astronauts. The X4 crew includes notable figures such as former NASA astronaut Peggy Whitson, who will serve as the mission commander, along with ISRO astronaut Shubhanshu Shukla as the pilot. Joining them are ESA astronauts Slaza Uznansky-Wisniewski from Poland and Tibor Kapu from Hungary, marking a milestone as the first Polish and Hungarian astronauts to visit the ISS. Whitson expressed her enthusiasm, stating, "Witnessing their selfless dedication and commitment to expanding horizons and creating opportunities for their nations in space exploration is truly remarkable." This mission not only highlights the collaborative spirit of human spaceflight but also underscores NASA's commitment to fostering international partnerships. The X-4 mission is expected to last up to 14 days, during which the crew will engage in a mix of scientific research outreach and commercial activities aboard the ISS. Dana Weigel, manager of NASA's International Space Station program, noted the significance of such private missions, stating, "As NASA looks toward the future of low Earth orbit, private astronaut missions help pave the way and expand access to the unique microgravity environment." This venture aligns with NASA's broader strategy to cultivate a sustainable low Earth economy, allowing the agency to purchase services from commercial providers while focusing on upcoming lunar and Martian missions. As excitement builds around the X-4 mission, NASA is also gearing up for ambitious endeavors beyond low Earth orbit. The agency's Mars Sample Return (MSR) initiative, a joint project with the European Space Agency, aims to bring Martian samples back to Earth for the first time. This multi-mission campaign is poised to revolutionize our understanding of the Red Planet and prepare for future human exploration. NASA has recently called for innovative designs to minimize costs and risks associated with this complex mission, with the goal of returning samples by the 2030s. In a related vein, the space industry is witnessing a surge in launch activity. Florida's Space Coast achieved a record 93 orbital rocket launches in 2024, and 2025 is shaping up to be equally busy. Upcoming missions include SpaceX's Starlink satellite deployments, Blue Origin's New Glenn test flights, and NASA's lunar lander missions, all contributing to an unprecedented era of space exploration that emphasizes both innovation and international cooperation. As we look ahead, the convergence of private and public space initiatives, highlighted by missions like Axiom Mission 4 and the Mars Sample Return, signifies a transformative period in human spaceflight. The collaborative efforts of international agencies and private companies are not only expanding our reach into space but also inspiring future generations to dream bigger and explore farther. With each mission, we draw closer to understanding our universe and our place within it, setting the stage for exciting developments in the years to come. NASA astronaut Sunita Williams has recently become the focal point of both admiration and concern as she continues her unexpected extended stay aboard the International Space Station (ISS). Initially scheduled for a mere 8 days, Williams and her fellow astronaut Butch Wilmore have now orbited Earth for over 8 months due to a series of technical complications with their spacecraft, the Boeing Starliner. Their situation encapsulates the unpredictable nature of space missions and raises important questions about the physical and psychological toll of prolonged space travel. During a recent interactive session with students from Needham High School in Massachusetts, Williams candidly shared her struggles with the effects of long-term weightlessness. "I've been up here long enough right now, I've been trying to remember what it's like to walk," she stated, highlighting the challenges of living in a zero-gravity environment. The astronaut's comments reflect a significant concern, as she admitted to having difficulty recalling the sensations of walking or lying down. This poignant revelation not only underscores the unique challenges faced by astronauts but also illustrates the mental and physical adaptations required for life in space. Williams' situation has not gone unnoticed, with public interest spiking following reports of her noticeable weight loss. In an earlier interview, she attributed her altered appearance to a phenomenon known as fluid shift, which is common among astronauts and can make their heads appear larger and bodies thinner. However, concerns about her health have persisted, prompting a NASA source to reveal that she had indeed lost a considerable amount of weight. Despite these worries, Williams has maintained a positive public presence, emphasizing her commitment to staying connected with her family and managing her well-being as best as she can. In a notable achievement amidst the ongoing challenges, Williams recently set a record for female astronauts by accumulating over 62 hours of spacewalk time, surpassing the previous record held by Peggy Whitson. This milestone occurred during a spacewalk alongside Wilmore, where they engaged in essential maintenance tasks, including the removal of radio communications hardware and the collection of microbial samples from the station's exterior. Williams' record-breaking feat highlights her resilience and dedication to her role as an astronaut even as she navigates the difficulties of an unforeseen extended mission. The duo's return to Earth is anticipated for late March or April 2025, when they are slated to be replaced by the next crew members during a planned SpaceX Crew 10 flight. Until then, Williams and Wilmore continue to adapt to their extended stay, with Williams expressing her focus on the present. Being deployed for a little while is not unusual for any of us, and that's part of the game. This perspective speaks volumes about the mental fortitude required for astronauts who face unpredictable circumstances in the vastness of space. As NASA and the space community closely monitor the health and well-being of these astronauts, Williams' experiences serve as a reminder of the complexities and unpredictabilities that accompany human space travel. Her journey not only underscores the resilience of the human spirit in the face of adversity but also paves the way for future discussions about the implications of long-duration space missions, a topic of increasing relevance as humanity looks toward future explorations beyond Earth. Eclipses have long captivated human imagination, from inspiring artists to fueling scientific inquiry. NASA's Eclipse Science Initiative underscores the dual significance of these celestial events, blending aesthetic allure with groundbreaking research potential. As we approach another series of solar eclipses, NASA scientists are poised to deepen our understanding of the Sun-Earth and the intricate interactions between them. Historically, eclipses have been pivotal in advancing scientific knowledge. For over a century, solar eclipses have allowed researchers to probe the Sun's structure, test theories such as Einstein's general relativity, and even lead to the discovery of new elements. In contemporary research, total solar eclipses are particularly invaluable. They reveal the Sun's faint outer atmosphere, the corona, which remains hidden under typical conditions. Instruments like coronagraphs can mimic the effects of an eclipse, yet they struggle to capture the nuances of the corona closest to the Sun, an area critical for understanding solar dynamics. According to NASA, studying this innermost corona is crucial for answering fundamental questions about the mechanisms of heat and energy transfer from the Sun to the solar wind. Given that the solar wind can significantly impact technology and life on Earth, gaining insights into its acceleration mechanisms is vital for predicting its effects on our planet's technological infrastructure. Moreover, eclipses provide a unique opportunity to study Earth's atmosphere under exceptional conditions. The localized dimming caused by an eclipse allows scientists to observe the Sun's influence on the upper atmosphere, where phenomena such as the ionosphere, vital for GPS and communication systems, are found. The 2017 total solar eclipse marked a significant moment for scientific observation, with NASA funding 11 studies to gather unique data. This eclipse made a remarkable journey across the contiguous United States, enabling extended ground-based observations that complemented satellite data. The insights gleaned from this event have informed predictions for subsequent eclipses, such as the 2019 event in South America and the 2021 eclipse over Antarctica. Such predictive models are instrumental in understanding how solar material travels through space, ultimately affecting conditions in near-Earth space, an area of research known as space weather. The importance of solar eclipses extends beyond solar physics. They also impact our understanding of Earth's atmospheric layers. NASA's global-scale observation of Limb and Disk Gold mission captured valuable data during the 2019 eclipse, revealing how such events affect the thermosphere, a layer crucial for satellite operations and communication technologies. A recent study published in 2021 analyzed over a decade of eclipse data, highlighting that the corona maintains a consistent temperature despite variations throughout the solar cycle. As we look to future eclipses, NASA continues to emphasize the scientific value of these events. The next total solar eclipse will occur in 2024, providing yet another chance for researchers to gather critical data about both solar and terrestrial phenomena. The insights gained from these observations will not only enhance our understanding of solar dynamics but also inform our preparedness for space weather events that can disrupt modern technology. The intertwining of art and science during eclipses serves as a reminder of our quest for knowledge and the beauty of the universe. As NASA continues its exploration of eclipses, the agency remains committed to fostering collaborations that bridge scientific research with practical applications, ultimately benefiting society at large. The future of eclipse science promises to unveil more secrets of our celestial neighbors and deepen our understanding of the complex interactions that define our solar system. In an era marked by unprecedented advancements in space exploration, NASA's Mars Sample Return (MSR) mission stands as a beacon of ambition and scientific endeavor. Set to be the first campaign to bring Martian samples back to Earth, the MSR initiative promises to reshape our understanding of the red planet and its potential for hosting life. This collaborative effort between NASA and the European Space Agency (ESA) aims not only to gather crucial geological data but also to lay the groundwork for future human exploration. The MSR mission is already generating excitement and speculation, particularly following the recent announcement of a new strategy intended to streamline the mission's architecture. NASA has committed to exploring innovative designs that reduce costs and risks while enhancing operational efficiency. On April 15, 2024, the agency called upon its community of engineers and scientists to contribute their insights and proposals, reflecting a commitment to harnessing both new technology and established methodologies. This will ensure that NASA is able to bring these samples back from Mars with significant cost and schedule savings compared to the previous plan, stated former NASA Administrator Bill Nelson. Central to this mission is the Perseverance rover, which has been actively collecting samples from Jezero crater, an area identified as having ancient conditions that may have supported microbial life. The rover's latest find, a sample named Silver Mountain, has been described by NASA scientists as possessing textures unlike anything we've ever seen before. This 26th sample, sealed in a titanium tube for future analysis, underscores the potential for these materials to provide insights into Mars' geological and climatic history. Perseverance's journey is remarkable. Since its landing in February 2021, it has traversed over 20 miles across the Martian landscape, gathering a diverse array of rock and sediment samples. The rover is currently climbing the northern rim of Jezero crater, where it is expected to collect additional samples that could further illuminate the planet's past. This will also prepare us to safely send the first human explorers to Mars, said Nikki Fox, who leads NASA's Science Mission Directorate, highlighting the mission's dual purpose of scientific discovery and human exploration preparation. NASA has indicated that the Martian samples could be returned to Earth as early as 2035. With the final selection of the return methodology expected to be announced in the coming year. This timeline aligns with the agency's broader goals to not only explore Mars but also to establish a continuous human presence on the planet in the future. As the mission progresses, the scientific community eagerly anticipates the revelations that these Martian samples will provide. In conclusion, the Mars Sample Return mission embodies a pivotal moment in space exploration, merging ambitious scientific inquiry with the practicalities of future human settlement. As NASA and ESA continue to refine their plans and gather groundbreaking data from the Perseverance rover, the coming years will undoubtedly bring profound insights that could redefine our understanding of Mars and its place in our solar system. The dream of exploring Mars is not just a distant aspiration but an unfolding reality, poised to inspire generations to come. As humanity continues its exploration of the cosmos, our celestial neighbors, particularly the Moon and Saturn, remain focal points of fascination. Recent developments from NASA and astronomical observations have reignited interest in these distant worlds, highlighting both historic achievements and upcoming celestial events that captivate both seasoned astronomers and casual skywatchers alike. The Moon, Earth's closest celestial body, has witnessed a storied history since the first human footsteps graced its surface during the Apollo missions. Notably, Neil Armstrong and Edwin Buzz Aldrin became the first two individuals to walk on the Moon during Apollo 11 in 1969. Over the course of the Apollo program, which spanned from 1968 to 1972, a total of 12 astronauts ventured onto the lunar surface. Today, 4 of these pioneering moonwalkers remain alive: Aldrin David Scott Apollo 15, Charles Duke Apollo 16, and Harrison Schmitt Apollo 17. The legacy of these astronauts continues to inspire future generations as NASA prepares for its Artemis missions, which aim to land the next humans on the Moon in the coming years. In addition to lunar exploration, February presents a unique opportunity for skywatchers as the full snow moon rises on February 12. This full moon, traditionally associated with winter's chill, will peak in brightness at 8:53 a.m. Eastern Time. The snow moon, so named for the heavy snowfall commonly experienced in February, has also been called the bald eagle moon, bear moon, and groundhog moon, reflecting the cultural significance of this time of year. The astronomical event coincides closely with Groundhog Day, creating an enchanting intersection of folklore and natural wonder. Observers are encouraged to catch the moon's display either before or after its peak, as bright sunlight may obscure the view during the peak time. Meanwhile, Saturn, with its 146 moons, continues to astound astronomers. Among these natural satellites, Titan stands out as the second largest moon in the solar system, boasting features such as lakes of liquid methane and an atmosphere denser than Earth's. Enceladus, another prominent moon, has captured attention for its subsurface ocean and geysers that eject water vapor into space, making it a prime target for future exploration. NASA's ongoing studies of Saturn's moons reveal their complex interactions with the planet's rings, providing deeper insights into planetary formation and the potential for life beyond Earth. As we look ahead, February promises to be an exciting month for astronomy enthusiasts, packed with significant celestial events. Following the snow moon, March will see a total lunar eclipse and a partial solar eclipse, further enriching the astronomical calendar. With longer days approaching as spring nears, skywatchers will have to adapt to changing viewing conditions, but the allure of the cosmos remains undiminished. The interplay between lunar phenomena and Saturn's intricate moon system exemplifies the ongoing quest for knowledge that defines modern space exploration. As NASA continues its ambitious plans for returning to the moon and venturing beyond, we find ourselves on the precipice of a new era in our understanding of the universe. The discoveries made in the coming years will not only illuminate the past but also pave the way for future explorations of our solar system and beyond.